So today's the other half of slope-intercept form, and we are going to be graphing with this. Now in the past I've had you graph, but we had a t-chart and you used the numbers -1, 0, 1, and 2, plugged them in for x to solve for y. Today we're going to use these notes, so feel free to use these notes as we go through. I'm actually going to come back to this one. It's a little trickier, so I'm going to start with some easier problems. So looking at guided practice on page 414, I'm starting with number 5. So my expectation for you guys is to write out the equation. Make sure it's in slope-intercept form, which is y equals mx plus b, which it's in that format. Then I want you guys to go ahead and write down the slope, which is what we did yesterday. So the slope is 1/3. The y-intercept is the +1, so we can just write 1. And this is how you go ahead and graph it. First, take the y-intercept, which is a +1, and on the y-axis, we're going to put a dot at the +1. So this is where this line is going to cross the y-axis at this +1. The slope, remember, we do the little saying, rise over run. So from this dot, I want you to rise the 1, oops, and then I want you to run to the right. So we rose 1 and run 3. 1, 2, 3. So my other dot's here. And I got that by using the slope. I could do it again. I could go rise 1, run 3, 1, 2, 3, and put another dot. You only need 2 dots to create, or 2 points to create a straight line. So with these two, we're going to connect them. Some kids will grab a ruler. I'm not going to get one out right now and pretend that was connected really well. So again, 3 points. 1 for your slope, 1 for your y-intercept, and 1 for your graph. Let's do number 7. So again, double check it's in the y-intercept form, or slope-intercept form, sorry. And so we have y equals 2x minus 4. The slope is in front of the x, that is a 2. The y-intercept, now this one you have to be careful, you need to grab that whole number, so it is a -4. So I'm going to go ahead, always start with your y-intercept, so start at 0 or at your origin, and remember it's going to be plotted on this y-axis. So I'm going to go -4, 1, 2, 3, 4. Put my dot here. Now my slope is 2, and slopes are always easier if you have it in a fraction form. So we can just put this over a 1, all right, because it's still equal to 2. So I am going to rise 2, 1, 2, and run 1 and go 1 over. And then I can go ahead and graph my points to the best of my ability. All right, now I want to show you one. I'm going to jump back to this in your notes. When I look at this, this is not in slope-intercept form. So I've got to change it. I want y to equal these two. So to get rid of a -5, I'm going to add 5, cancel. So my new problem looks like this. Y equals -x plus 5. My slope would be a -1, but again, fractions are easier, so I'm going to say a -1 over 1. My y-intercept is a +5. And to quickly graph this for you guys, the y-intercept, so on the y-axis, I know I need to go up 5. 1, 2, 3, 4, 5. So I'm going to put my dot here. Now watch, this is going to be a little bit different. This -1 is going to tell me to go down 1 and then over run 1. So I really should have a couple dashes here. So then this is where my dot is here. And that's what it would look like for this. If you're looking at number 9 is a story problem, and because you have 2 story problems on your assignment today, I thought I would run through one. They give you the equation. This one happens to be in slope-intercept form. There's no number here, but we know that that's technically like a -1. I might even, when I write my note right away, I'm going to write it as a -1, sorry guys, over 1. The y-intercept is 60. There's no way I'm going to go ahead and graph that high up, okay? Like going 1, 2, 3, 4, 5. So as long as you label the intervals, it's okay. So I'm going to go ahead and put my 60 as my y-intercept. This one's a little tricky. I mean, because I'm going by tens, it would mean that I'd go down 1 over 1. So it would be right around here. If I was going by tens, look at this. If I were to write -10 over 10, isn't that equal to -1 over 1? So for this one, I might even think about if I go down 10 over 10, it might be easier to graph it. But otherwise, the down 1 over 1 works. It's just that it's so small. And that's what it looks like. One thing I thought of while I was quickly doing this, if I were to have had something like y equals 1/3 x like this, my slope is 1/3. My y-intercept, there is a y-intercept, but if you don't see it, it's the same as 0. So again, I'm doing this very quickly. My y-intercept is the origin. And then the slope would say go up 1 over 3. So just to give you an idea, if you ever just see it in this format without that y-intercept there, we just know it as 0. Oh, sorry, let me go back. B does ask a question for 9. I gotta reread this. It says, describe what the y-intercept and the slope represents. So the altitude of the height can be represented by this, where x is the time in seconds. So this is feet, this is seconds, and so we know at 0 feet, let me reread this, I'm sorry guys, describe what the y-intercept and the slope represents. We know that at 0 seconds, the kite's at 60 feet. At 1 second, so remember, it went down 1 over 1. At 1 second, it would be at what? 59 feet. At 2 seconds, it would be at 58 feet, and so forth. So again, describe what the y-intercept and the slope represents. The slope, the y-intercept, represents how tall the kite is at 0 seconds. The slope represents that the height decreases 1 foot every 1 second.